Let's look at the examples on your notes paper. This is example 1. It asks you to find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. So if you can picture this, you would have a circle here, and the arc that we're looking at basically is covering an angle. This angle here is 30 degrees. So we are looking for the length of this arc right here, knowing that the radius is going to be 10 meters. So we need to figure out what is that length there. So we know from our formula, the arc length equals theta times the radius, but we have to keep in mind that theta is always in radians. And unfortunately here, we gave theta in degrees. But 30 degrees, that's something we're very familiar with. We know that that is equivalent to pi over 6 radians. So we're going to use pi over 6 radians in our formula. So our arc length is equivalent to pi over 6 times the radius, which we know is 10 meters. So multiplying this, we would get 10 pi over 6, which we know is equivalent to 5 pi over 3. And I want you to think about what your label would be here. It's the length of this arc. Well, the length of the radius is given in meters, so the length of the arc is also going to be in meters. Now, if I had asked for an exact answer, this would be it. This is an exact distance. But typically, if I told you, hey guys, I ran 5 pi over 3 miles today, you would look at me like I'm crazy because we don't typically talk about a distance in terms of pi. 5 pi over 3 doesn't really mean a whole lot to us. So if I don't ask for an exact answer for an arc length and you're gonna give an approximate answer, I usually say round to the nearest hundredth. But if I type 5 pi over 3 in my calculator, I get 5.24. And 5.24 meters means a heck of a lot more to me than 5 pi over 3, right? If I say 5.24 meters, you can actually picture what that might look like. So this is an approximate answer. If I don't ask for whichever one, you're free to give whatever. For me, the approximate answer makes more sense in the context of a problem, so that's probably what I would stick to. So let's keep going. Example 2, a central angle theta in a circle of radius 4 meters is subtended by an arc length of 6 meters. Find the measure of theta in radians. So again, we're going to use our arc length formula, S equals theta times R, or R times theta, however you want to write it. Theta, again, it's always going to be in radians. So the fact that my answer is asking for it to stay in radians, that's a good sign. We don't have to convert anything. We know the arc length, that's 6, so I can plug in 6 for S. We are solving for theta, and then our radius is 4. So when we go and solve for theta, getting that by itself, we're going to divide both sides by 4. So theta equals 6 over 4. We can reduce that to 3/2. And you can keep it as that. If you really want to, you could change it to 1.5. Remember, our label here is radians. If you don't put a label on, I always assume it's radians, but in a problem like this, I like to physically go through and label that. Example 3, we have a car's wheels are 28 inches in diameter. How far in miles will the car travel if its wheels revolve 10,000 times without slipping? So we're going to break this down a little bit at a time. If you haven't tried it yet, I'd love for you to try it on your own and then check back in with me. But let's talk about just one revolution. Okay, instead of revolving 10,000 times, let's look at one time. So we've been working with arc length, and we've been saying that's R times theta. Well, I want you to think about for one revolution, if you're going all the way around a circle one full time, then going that distance, that's going to be 2 pi radians. So in this case, your theta is going to be 2 pi. And our radius was given to us, except it was given 28 inches in diameter. So we know that if 28 inches is the diameter, that means that distance for the radius is going to be half of that, so 14 inches. So if we take 14 times 2 pi, an exact answer is 28 pi, and then our label is going to be in inches. So this would be the distance that the wheel covers for one revolution. So if we're talking about 10,000 revolutions, we just need to take 10,000 and multiply it by 28 pi. And when we do that, we get 280,000 pi inches. And That's your answer if we were okay keeping it in inches, right? 280,000 pi, we would be able to type that in our calculator, but for right now, I'm going to leave it like this because my job is to now convert this into miles. So we're going to do some dimensional analysis here, your guys' favorite. So we need to take 280,000 pi, and let's label it. This is in inches. Our job is to get it into miles. So what you're going to be doing is multiplying by different conversion factors so that you eventually move from inches into feet and then maybe into miles. So I know that there are 12 inches in a foot. So when I'm multiplying, I either have to put 12 inches over 1 foot or 1 foot over 12 inches. I choose to put 1 foot over 12 inches, and the reason that I do that is because I have inches in the numerator over here, and in the denominator here, they're going to cancel. So when I start multiplying this, so far now I'm in feet. And then I know there are 5,280 feet in a mile. So the question is, do I want to multiply by 5,280 feet over 1 mile or 1 mile over 5,280 feet? And the option that I'm going to go with is 1 mile over 5,280 feet. And again, that's because I have feet in the numerator, feet in the denominator. They're going to cancel. So when I type this in my calculator, I have to do it very carefully, but I'm multiplying across, so I get 280,000 pi divided by 12 times 5,280. And be careful when you type this in your calculator. You need to make sure that's in parentheses if you're going to type it all in at once. We're going to get an approximate answer here because, again, that's going to be what makes more sense to us. Thinking about a distance, we don't want that in terms of pi. And when we type that in, we get about 13.88 miles. We're going to do more practice when it comes to dimensional analysis, but hopefully you kind of remember how we change those units by using those conversion factors.